Next thing we have to take a look is the equation of planes in three-dimensional space. Usually, the plane defined by single point on the plane and normal vector perpendicular to that plane of surface of the plane. So let me give you the genetic definition of the plane in space based on the mathematical expression. So the plane in space, basically if the plane contains the point x1, y1, z1, and it has non-zero normal vector which is perpendicular to the surface of the plane A, B, C, then that plane can be represented by the standard form of the equation of the plane, which is given by A times x minus x1 plus B times y minus y1 plus C z minus z1 equals 0. That is standard form, but this equation could be converted into general form. So if you expand this bracket, fully extend that expression out of bracket, then it should be AX. So they plug the A, B, C coefficients into the bracket, and they expand the terms out of the bracket. Then that should be A minus AX1 plus BY minus BY1 plus CZ minus CZ1. Then you you add all x, y, z terms first, AX, BY, CZ, and then all constant terms in the same bracket. So that should be minus AX1 minus BY1 minus CZ1. And the bracket could be replaced with the constant parameter D. So in this case, this equation could be expressed with AX plus BY plus CZ plus D equals 0. That is called a general form of plane. Okay. Let's check how this definition of the plane is expressed with the example problem. So example problem number 3. So we have to find the general equation of the plane passing through the points 2, 1, 1, and the 0, 4, 1, and minus 2, 1, 4. As I said, you can pick up any of these 3 points as a reference point, x1, y1, z1, and then use the point to find out the vector, normal vector, perpendicular to the surface of the plane. So let's just plot this 3 point in the x, y, z coordinate. So let's move on to the next one. So here, let me just draw that plane with the 3 points. That should be x, y, z, and the first point P is located 2 in x, 1 in y, and z the 1 and z. So that's somewhere here, I think. So that is P, that is 2, 1, 1. And the second point, Q is the 0 in X and the 4 in Y and 1 in Z. That should be the somewhere here. Okay, that is Q 0, 4, 1. And last point is minus 2 in X, 1, 2, and 1 in Y, right there, and 4 in Z, right there. So that should be somewhere here. So if you connected all 3 points with a straight line, then your plane should be like this. So that is R minus 2, 1, 4. So the first step, this one, we set up the P as reference point, which is X1, Y1, and Z1. And you gotta just use this 2 point as the terminal point for two vectors, U and V, right? So let's check the U vector first. So that is U vector is 0, minus 2, and 4, minus 1, and 1, minus 1. So that is minus 2, 3, and 0. And the vector U should be minus 2. This is like PQ, right? And that should be minus 2, minus 2, and then 1, minus 1, and the 4, minus 1. So that is minus 4, 0, 3. That is RQ. So we just defined two vector. The next step, we have to justify the normal vector out of this one. So normal vector could be given by the cross product of two vectors, V and U. So normal vector, first of all, we gotta just find the cross product out of these two vectors. So that is I, J, K, and the minus 2, 3, 0, and the minus 4, 0, 3. So X component of this vector from the cross product is 3 times 3 minus 0 plus J, 0 times minus 4 minus 2 times 3. And G component is minus 2 times 0 plus, minus, like minus 4 times 3 in K. So if you do that, then that vector out of a cross product is 9I. And as you can see, that is 6J. And now this one just gone. And then that is 12K. So that is the vector out of cross product of U and V. So now next step is just normalize this vector with magnitude of this vector. So that should be the normal vector. So that is U. First of all, you have to find magnitude of this vector. So the magnitude of this vector is, you have to, so that is actually simplified. If you take a 3 out of it, then that is 3I, 2J, and the 4K, right? So the magnitude of this vector is the square root of the x component, y component, and z component. So that is 3 times square root 3 squared 2 squared plus 4 squared. So that is 3 times 29, right? That's magnitude of this cross product vector. Now, next step is to define normal vector out of this. Normal vector, unit normal vector is the cross product vector normalized by the magnitude of it. So that should be 1 of 3 square root 29 times 9i 6j and 12k. So if you take 3 out of this x, y, g coefficient, then that should be 3, 1 of square root of 29, 3i, 2j, and 4k. Now, we know this is A, this 2 of square root of 29 is B, and the 4 of the square root of 29 is C, right? So now you can use this ABC to define the equation of plane. And that plane should pass through this reference point, x1, y1, z1. So with plugging those coefficient into standard form, we can find out the general equation, general expression of the plane. So that is now the A is what? 3 out of square root of 29 x minus x minus the 2 plus this is x, right? And then okay. Right, then the y is the y is 2 square root of y minus 1, and z is the 4 square root z minus 1 equals 0. So you just take this square root 29 out of this one, you can multiply square root of 29 on to the first, second, third, the x, y, g terms, then that should be 3 x minus 2, 2 y minus 1 plus 4 g minus 1 equals 0. So that is the standard form of this plane. Standard form. Now you can convert into the general form of the expression. So if you just plug 3, 2, 4 into the bracket, then that should be 3x minus 6, 2y minus 2, 4z minus 4. So now you combine x, y, g, 3 terms all together in the same row, and then add all constant value as a t. So that should be 3x, 2y, 4z, and that is minus 6, minus 2, minus 4. So that is 3x, 2y, 4z, minus 12 equals 0. So that is general form of plane. So now we've been looking through this example problem, and that give us how to actually use this definition of plane and how to solve, how to find that the equation of plane using the given condition, three different points.